I picked out 3 different practice problems for us to work on that are a little bit harder than the ones that we saw in the first video. So let's just jump right into it with our very first one, figuring out how many of each element we have on each side. So for this we have Ag, Cl, Mg, I. Alright, again, I would maybe pause your video and see if you can work through part of this problem. And then unpause it and see if you're doing it right, and then maybe repause it and keep trying to work on it to try to see how much you can do, because that's what's going to help you the most. Alright, so I'm going to figure out how much of each element I have. I have 1 Ag, 1 Cl, 1 Mg, 2 Is. Again, if you're confused about where we're getting this, remember we're always looking at the little numbers that are by each of the elements. So in this one, we only saw that over here on this side, we just had a 2 by the I. So that's why all the other ones got 1, we just had the 2 by the I. Now on the other side, the Ag doesn't have a number, so it's a 1. The Cl, it's over here, so it actually has a 2. Mg has a 1, and I has a 1. Alright, now we need to work on the balancing part. So, Ag looks great. Cl doesn't look great, so we need to multiply it by 2 because we want this to equal that. Now remember, if we ever multiply by 2, we have to make sure that we put it in front of our whole molecule that the Cl is a part of. Since Cl is a part of this molecule, we have to put a 2 up front. So when we put that 2 up front, remember that 2 now is multiplied not only to the Cl, but it's also multiplied to the Ag. So we actually have to times our Ag by 2 to get 2. Now let's keep seeing if this is balanced. Mg, balanced. I, that's not balanced, right? We have a 2 and we have a 1 over here. So to fix that, we have to multiply this by 2. We get 2. Because we're doing that, remember, you need to put it over here in your problem in the molecule that has the I in it. So let's put a 2 up front. So since it's being multiplied to the I, that's good. We also need to multiply it to the Ag. So times by 2, and we get 2. Now we can always double check our work to make sure we did it right. So we have 2 Ags, perfect. 2 Cls, perfect. 1 Mg, perfect. 2 Is, perfect. Alright, this next one's also going to be kind of tricky and hard. So yeah, pause the video if you didn't get that. But let's work on this other one down here. So we're going to have C, H, and O. And on this side we're going to have C, H, O. And I'm actually going to add a second O. You can figure out how you like to do this. You don't have to do it this way. But this is what I like to do, since you'll notice these O's are actually in different molecules. So if we ever times one O by a number, we don't want to put it on both of them. So we want to kind of separate them out. Alright, but I'll explain it as we go through to hopefully help you understand. So let's start with our left side. We're going to have 1 C, we're going to have 4 H's, and we're going to have 2 O's. We're going to have 1 C, we're going to have 2 H's, and then this O without the pink underline is going to be 2, and this O with the pink underline is going to be 1. So let's start balancing our equation. So you'll notice that our C's are 1 and 1, so that's good. Our H is 4, this H is 2. So we have to actually multiply this one by 2 to get 4. When we do that, remember, we have to put a 2 in front of where our H is. So since we have the H here, we have to put a 2 right there. And when we do that, we multiply it to the H and we multiply it over here to the O. And so this helps us to know that we're only multiplying this pink O by 2. And we're going to get 2. Alright, so we did that. Now let's look at our O's. So when we look at our O's, we have 2 over here, and over here we have 2, and then another 2. So if we have 2 and 2, I like to kind of put them off to the side like these ones both, they add up to be 4 total. So we need to think about what we have to times that O by to get it to be 4. So hopefully in your head you're thinking 2, because that's easy math to get 4. Remember, if you multiply it by something, you have to also put it up here in your equation. So that is your balanced equation for that one. There's going to be a couple like that on your homework or things like that. So make sure you feel comfortable and that you ask questions if you're not really sure what's going on, okay? And I can try to explain it in a different way to you. Alright, the final one is the hardest one, I think. So first start off by figuring out how much of each element is in the problem. Alright, so we have 1 Al, we're going to have 1, and we're going to have 1. On this side, we're going to have 1, we're going to have 2, and we're going to have 3. Now I'll show you how lots of people start this problem. So we say our ALs are balanced. We look at our H's, we say our H, we need to times this h by 2 equal 2, so we put a 2 here. We also need to times our CL by 2 to get 2. So then we move on to our next one because we see our h's here are balanced. So then we look at our CLs, and our CLs aren't balanced, so we're like, oh, we have to multiply this by another number. But then that gets kind of confusing. So what I would do is I would see that that doesn't work and then erase my work and try it again, knowing that 2 is not the answer. We can't multiply it by 2 to get our answer. I'd also look at this and say, okay, both of these ones are 1. So that means when I multiply a number, since they're connected, whatever number I put here and I multiply them in, these ones are going to have the same exact number. If I look on the other side, we're working with a 2 and a 3. So I have to think about a number that I could multiply 2 by to get, and I can multiply 3 by to get. So think about what number could you divide 2 into, and you could divide 3 into. If it helps you, you could think about, okay, would 4 work? If I could divide 2 into 4, that works, but I can't divide 3 into 4. That doesn't work. Does 5 work? Can I divide 2 into 5? No. Does 6 work? Can I divide 2 into 6? Yes. Can I divide 3 into 6? Also yes. So we're going to actually multiply these by 6, because that's going to be the best number that we're going to be able to fix the other side with. So put a 6 in there. Alright, so now we look at our other side. We see our ALs, they're all good. So now our H's, we have a 6 here and we have a 2 here. So we have to multiply this by 3. That equals 6. The next one, we have a 3. Oh, let's remember to put this number in before we forget. So let's put that 3 up here. There. So this next one, we have a 3. We have to multiply that by 2 to get 6. And we have to put our 2 in up here. Now remember, since we put the 2 in for the whole molecule, it already was multiplied for that Cl. We have to do it for the Al as well. So times by 2 to get 2. If we're looking at our work, we'll see our CLs are 6 and 6, our H's are 6 and 6, but our Al is 1 and this Al is 2. So we actually have to multiply this Al by 2 on this side. Make sure you put it up front to get 2. And so that is your answer. This is probably about the trickiest thing that you'll see on your test. At least, especially if you're a normal student, this is about as tricky as we'll see for this class. So if you feel like you could do all of these and explain them well, you'll be fine. We're going to do a little bit more practice with it. So try the worksheet, see how it feels, and we'll probably do another practice worksheet later on because this is an important concept that takes a while for students to get. So let me know if you have any questions. Always come on Friday to get help. I'm happy to help you. I sit there by myself all day, so I'd love to see your face. All right, have a good rest of your week, guys. See you later. Bye.